Is up? Hello everyone. I'm back with problem number 23, video number 23 from the AP Physics C Mechanics multiple choice test. I'm getting through 35 of these videos, so stay tuned for the rest of them. Hopefully these videos will vastly improve your physics knowledge and get you ready for the AP test in the spring. Alright, so the problem we have here is the figure. This one right here, it's a free body diagram. Let's label that. Make sure we know what this is. Free body diagrams are very important. The figure shows the directions and relative magnitudes of all three forces acting on an object. Which of the following vectors best shows the direction of the object's acceleration? So we're given vector A, B, C, D, and E, each pointing in different directions, and our job is to figure out which of those directions matches with the direction, the vector that this object will follow as it accelerates based on these three forces. So this is basically a free body diagram problem. There's no summing the forces or anything. There's no math involved. You can really just eyeball it and figure out which one the right answer is. Like add these things in your head. What does it look like? It looks like A. Yes, it is A. But let's talk about this a little bit more mathematically in terms of vector addition. So, the way you can add vectors, there's a couple ways, but let's do I think it's called the head to tail method. Let's add these two vectors first, the bottom two ones. So, we have the vector going like this, the vector going like this, of approximately equal magnitude. So, the head to tail method, you're going to copy this vector down, the top vector here, and then copy this one here like in parallel, and then adding them going from the start to where both end up. So you're going to get a vector like this. Obviously these lengths I'm drawing aren't exact, I'm freehanding this all. And then we can add this to the third vector that we didn't add before. So I'll just add it right here. So again, this vector has these basically have the same magnitudes approximately just from eyeballing it. This one is a good amount longer, which we're going to take into account with this. So if you average these out, it's going to look approximately like something like, oh, that's way too long. Something like that. Something like this. Which, out of all of these, matches A best. Yeah, it's a free body diagram problem. You're adding the vectors. Fairly straightforward, about as easy as these problems get. I'll tell you, some of these problems in this test are very difficult. This is not one of those. This should be an easy point. Yeah, you're taking the average of the vectors, you're eyeballing it, you're doing head to tail method, whatever method works for you in terms of vector addition. I know there's a couple other ones out there. I'm not going to go into explaining them all. This isn't a math video series. This is about physics, so that's what we've got. But yeah, that's how you add vectors. That's how you do this problem. We can talk about free body diagrams a little bit. So there's some different ways to do it. You can just label, like for this object, you can always kind of just label something as a point. So you can have your forces. You can label it as a box, as they do here. And when you draw your own free body diagram, I don't know if they have questions. I'm pretty sure they have free response questions on the test where they're going to ask you to draw them, but a lot of the time when you're drawing them, it's just for your own sake. It's so you can visualize the forces, and a lot of times you're going to use free body diagrams to start summing the forces. So you can sum the forces in the x or sum the forces in the y direction. Sorry for that handwriting. That's supposed to be an F to represent forces. But yeah, so for example, we could label this like, we can say this is friction, force of friction. We can say this is mass times gravity. And then, I don't know, let's call this like any type of force. Force of What is this object? Let's call it, what does it say? We can call it a box. So force of person on box, let's just say PB. The first letter represents what is acting the force on the second letter, second abbreviation here. So just some examples of drawing free body diagrams. Again, this is a straightforward problem. Thank you for watching. Please check back in for video number 24, and good luck with your studying.